Okay, tomorrow is the big day, our test over Unit 3, and that is integer operations. Our first question has a girl who has 5 cards, and to find her score, she has to find the sum of her cards. Now, this is not finding the sum like we do with just positive numbers. So if you need more info, you can look on page 18 of your notebook to see how we combine multiple integers. And so we use a T-chart for this. We separate out our positives and our negatives. So for our positives, we have 5, 3, and 11. And for our negatives, we have -2 and -6. Because these are all the same sign and these are all the same sign, we can find the sum. And so I total up how many positives I have. 5 plus 3 is 8, and 8 plus 11 is 19. Then I total up how many negatives I have. I have 6, and then another 2 makes a total of -8. Once we get down at the bottom, we have different signs. Different signs, we find the difference, which means we subtract. 19 minus 8 equals 11, and we have more positives, so our answer is positive 11. So her score in that game would be positive 11. And I do have a separate video for combining multiple integers if you want more info on that. Our next one is talking about modeling an integer problem. You can find that on page 16 of your notebook. So up at the top, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 negatives. So that right there represents -12. And we have 1, 2, 3, 4, 5, 6 positives. So that represents +6. Here we see -12 plus +6. Here we see -12 plus +6. So that looks good. They both have different answers, so I'll come back to that. 6 plus 6 equals 12. That is true, but that's a kindergarten problem. We're not here to model kindergarten problems. We have negatives up here, and there's no negatives in that answer choice. So we're going to get rid of C. And then D has the 6 positives, that's true, but it shows only 6 negatives, and there were 12 negatives. So that right there is wrong. And also, even if 6 plus -6 was being modeled, 6 plus -6 would equal 0. That would equal 0, not 12. So we can get rid of D. So the difference comes down to the answer here. Remember that we can get rid of all of these 0 pairs, and whatever is left over is our answer. So we have 1, 2, 3, 4, 5, 6 left over, but they're not 6 positives, they're 6 negatives. So this right here is wrong, and this right here is right. So B is our answer for that one. And I believe I also have a video for that too. Okay, question number 3. Which of the following have a value of -8? Choose all that apply. So some of them will be correct, some will be incorrect. There are 3 different page numbers for this, so I will go one at a time. Page 17 can help you with adding integers. So that would be this problem, and this problem. So I'm going to do those first. On page 17, it tells you to look and see if you have same signs or different signs. So here we have same signs. Same sign, we find the sum, which is 8, and we keep the same sign. So that one does equal -8, so that I would choose. On this next one, -3 plus 5, that's different signs. Different signs, we find the difference, which means we subtract. So that's 2, and we have more positives, so it's +2. So I'm not going to choose that one because it does not equal -8. 4 plus -4, that's different signs. Different signs, we find the difference, which is 0. 4 minus 4 is 0. And there's no such thing as positive or -0. It's just 0. Okay, so that's on page 17. Page 19 has subtracting integers. So down here we see a subtraction problem. And on the page about subtracting integers, it first tells you to box them. It also tells you if you see a negative like that, it turns into a big plus sign. So now we have different signs. Different signs, we find the difference, so we subtract. 11 minus 3 is 8. We have more negatives, so it is -8. So I'm going to choose that one because it also equals -8. The last page number for this one is page 21. Page 21 talks about Dorito Man. Remember that Dorito Man stands for division and multiplication. So here and here we have multiplication problems. So that means that we should be using Dorito Man for both of those. So on this one, we have a positive times a negative, so our answer should be negative, and 4 times 2 is 8, so negative 8, so I am going to choose that one. Here we have a negative times a negative, which should give us a positive answer, so that one is actually positive 8. So these three were the ones that equaled negative 8. Question number 4 is a number line problem. Which expression is represented by the model below? You have 2 pages in your notes about modeling on the number line, but the ones that look like this are on page 20. Remember that wherever you end up on these number line problems is your answer. So right away, I noticed my answer should be negative 15. So I'm going to get rid of these 2 because if the answer was 3, it would be over here, and if the answer was 1, it would be over here. Another thing I notice here is that Dorito Man would tell me that a negative divided by a positive would actually equal negative 1, so this isn't even true. Now this one is true, but there's nothing up here that's modeling that. So if we look at the differences here, they both have the same answer. They both are multiplying something times negative 5. The difference is one is 3 times negative 5, and one is negative 3 times negative 5. So the first thing I noticed on D is that, again, Dorito Man tells me that a negative times a negative is actually positive. So this shouldn't even be negative 15. So even if that was what was being modeled, I wouldn't choose that answer because that's not correct. Now, 3 times negative 5 is negative 15. So a positive times a negative comes out negative. And each one of these arrows is going 5 units to the left. And that's happening 3 times. So it's 3 groups of negative 5. 3 groups of negative 5 equals negative 15. So C is your answer for number 4. On the back for number 5, you have another number line problem, but this time it is an addition problem, and you can find that on page 16. On page 16, it tells you that we always start at 0. You'll notice all of these do start at 0. If we're going to the right, it's modeling a positive number. If we're going to the left, it's modeling a negative number. And we're looking for one that's modeling negative 3 plus 2. So my first one, it starts by going to the right 3 units. So that's actually positive 3. And then it goes to the left 2 units. So that's adding negative 2. So that's 3 plus negative 2 instead of negative 3 plus positive 2. I'm going to get rid of A. On the next one, it does go to the left first, but it only goes 2 units to the left. So that's negative 2. And then it goes 3 units to the right. So that's negative 2 plus 3. Still not what I'm looking for. The next one starts by going 2 units to the right. Remember, right is positive, so that's positive 2. Then it goes 3 units to the left, so that's adding negative 3. So that's not what I'm looking for. The last one goes 3 units to the left, that is negative 3. Goes 2 units to the right, that is positive 2. It ends at negative 1. Remember that negative 1 should be our answer, and if we just double check up here, these are different signs. Different signs, we find the difference, which is 1. We have more negatives, so our answer should be negative 1. And so another way I can know that this one and this one are not my answers, they both end at positive 1. C does end at negative 1, but it's just not the right problem that's being modeled. So D is the answer, has the correct problem and solution. Okay, next problem is number 6. You can find information about number 6 on page 22 of your notebook. On page 22, we learned that we have to use GEMDAS to solve this problem. We have to use the order of operations. G stands for grouping symbols, and we do have some grouping symbols here. So that's what we're going to start with. Don't forget that you also have to follow your integer rules. So we have to use Dorito Man because we're dividing integers. So a negative divided by a positive gives us a negative answer. So that's going to be negative 3. And then I'm going to rewrite the rest of the problem. We're done with our grouping symbols. We don't have any exponents. We don't have any division or subtraction. We have multiplication and we have addition. We always multiply before we add. So this right here is our multiplying. And again, we still have to follow our integer rules. So we need to make sure we do Dorito Man. A positive times a negative gives us a negative answer. So that's going to be negative 20. Okay, then all we have left is the addition. Remember that we have to see if it's same signs or different signs. So this is same signs. Same signs, we find the sum, we add them together, and we keep the same sign. So our answer for that is negative 23. Number 7 also uses the order of operations. So you could look at that on page 22. So again, we're going to follow GEMDAS. This looks like a scary problem. It has a lot going on, but it's actually pretty easy. So we do have to start with our grouping symbols, but there's a bunch of stuff going on. And this was actually supposed to be a plus sign, so ignore that that is a division sign. Okay, so we've got addition, 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 and then we also have some multiplication. So even inside the grouping symbols, we still have to follow GEMDAS, which means we have to multiply before we add. I would just go ahead and do both of those in the same step. I would do 3 times 4 is 12, and I would do 6 times 12 is 72, and then I would rewrite everything else exactly the same. We can't get rid of the parentheses yet because we haven't solved everything that's inside of the parentheses. So we're still not done with the GEMDAS, or with the G in GEMDAS. All we have left inside of our grouping symbols is addition. So you could just go ahead and add all of those up at the same time. 6 plus 4 is 10. 10 plus 12 gives you 22. And I'm sorry about the lighting. The sun keeps coming in and out. So we're at 22. And then I would come over here and get the 1, add that to the 22. That's 23. Now we just have to do 23 plus 72. And that gives us 95. So all of the stuff in the parentheses just equaled 95. So we're now done with the grouping symbols. We don't have any exponents. We don't have any multiplication or division. We don't have any addition. We just have the subtraction. And 100 minus 95 is just 5. So like I said, that looked kind of like a confusing problem. But once you just look at the order, it's actually pretty easy. Last problem is number 8. And I'm going to see if I can fix my lighting really quickly. Okay, let's see. Did that help? It's coming back. Okay, so Jeanette writes 3 integers, and this is supposed to say 3. Negative 11, 2, and negative 4, and we want to know the sum. Again, this is on page 18, where you could find how to make a T-chart. We've got just 2 under positives, and we've got negative 11 and negative 4 here. We total up our positives and negatives. So we just had the 2, but this totals to negative 15. Once you get down here, you have different signs. Different signs, we find the difference, which is 13, and we have more negatives. So our answer is negative 13. If you have a griddable like this, you need to make sure you mark if your answer is positive or negative. So here we have a negative number. It's not 0.13, so I don't want to put it over here. It's 13, which would go right here. Don't put it over here because this is the thousands place and the hundreds place. You have to use the correct place value. I hope this was helpful. I hope you are going to do great on your test tomorrow. Good luck, and let me know if you have any questions.